In this video, we're going to look at a couple of different scenarios not covered in other videos dealing with Newtonian motion and forces. Here we have a 20 kilogram block that is at rest on a frictionless table. There's a 5 kilogram block that is attached to a pulley, and a string is also attached between the two blocks. And we're going to look to solve for the acceleration of the system. First, what we want to do is we want to draw free body diagrams for each of these objects. If we look at the 5 kilogram block, there's only the force of gravity that's pulling it down. The force of tension on the string is going to be measured later, and that's going to change as the system becomes dynamic, but we're not going to look at that just yet. So for us, right now, the only force is a 50 Newton downward force of gravity. The 20 kilogram block has the force of gravity acting on it, but also the normal force of the table is pushing it back up. So its net force is 0. So the only net force acting on the system right now is just the 50 newtons of gravity. In order to solve for acceleration, it's going to be equal to the net force divided by the total mass. Because both of these blocks are connected by this string, they're both going to start to accelerate at the same rate. So I just add the masses together. So 20 plus 5 equals 25 kilograms. So 50 newtons divided by 25 kilograms is just going to be 2 meters per second squared. Well, that was pretty easy. Well, let's look at the same situation again, but now there's a friction force. So we're going to say mu is going to be equal to 0.1. It's going to be a very low friction force, but we just want to include it in our problem. So now we have to go back and look at our new net force. Well, how do we solve for friction force? The friction force is equal to mu times the normal force. So if I have a 20 kilogram block, there's no other upward components of force acting on it. So the normal force is equal to the force of gravity. So F sub n equals F sub g. And the force of gravity is mass times gravity, mg 20 times 10 equals 200 newtons. So if the normal force is 200 newtons and mu is 0.1, it's a coefficient, it has no units, that means the friction force is going to be 20 newtons. So once again, the only force in the positive direction is my 50 newtons, but now I have a 20 newton net force that's acting, a 20 newton friction force that's acting in the opposite direction. So my new net force is going to be 30 newtons. So 30 divided by 25, is going to give us our answer. Now, if we want to look at another type of problem, we'll have to set up a new situation. So here we're looking at two pulleys. One pulley has a mass of 7 kilograms and the other has a mass of 9 kilograms. And we want to solve for the acceleration of this system. Both of these, the force of gravity is acting on them. And here it's just mg, 7 kilograms times 10 meters per second squared is 70 newtons. 9 kilograms times 10 meters per second squared is 90 newtons. Now, both of these force vectors are pointing in the same direction, but they both can't go down. So the larger force is going to win. So 90 newtons minus 70 newtons equals 20 newtons. So I found the net force just like before. Acceleration equals net force divided by total mass. 20 newtons divided by 16 kilograms is going to give us our answer of 1.25 meters per second squared as our rate of acceleration. And those are the main two other problems we haven't covered yet. All right.